Hi guys, thanks for watching again. In this video I will be building one of these LED lamp kits with the E27 socket. So let's first get all this stuff out of the bag. Let's see what's in there. I've bought 4 of them, don't know why, and I've bought them over a year ago. But we received a letter from the Dutch postage service, that the mailman actually had stolen several mail pieces, and these 4 lamps were one of them. And yeah, I actually forgot about them, but I checked eBay and I ordered them in August last year. Let's see, we've got 2 black wires, probably not that good visible on this desk, for diodes, probably, yeah, 4 diodes to make a bridge rectifier, a full bridge rectifier, a capacitor, because this circuit is a capacitive dropper circuit, so this one goes on here, the polarity doesn't matter. Diodes go over there, and then we have a R3, R2, and there must be an R1. R1 is over there, that is the discharge resistor. Now, yeah, let me get that in focus. R3 is obvious, it is 100 100 ohms probably. Let's have a look, let's get the eBay listing. Doesn't have this soldered, so let's see, what do we have here? Ooh, that is very visible, but it looks like yellow, purple, yellow, so 474, that is 47K. And another one, 47, probably the same. And brown, black, brown, which is 101. So 10, it's 10, and then add 1, that is 100. So this one goes over there, so these go over there. Easy. And there's a C2, which is this one. So let's first start by building this circuit. Let's get some cheap solder. And let's put this on there. Let's keep it a little bit. First, let's do the discharge resistor. 47 kilo ohms. Put it on there. There we go. Let's do it R2 at the same time. There we go. And why not do this one also? Goes over here. Right. Let's clean the iron. That's better. Let's see if this very light board, if it's a little bit, it's doable soldering it, but it is. That's better. Ooh, that is actually a very nice, good old circuit board smell. 80s style circuit board. I don't know how to describe it. Oh, lovely. Oh, yeah, I must have missed that smell. Awesome, awesome, really awesome. Now, this snips. It's actually a Chinese replica of the Xuron snips, and it works perfect for me. And the nice thing of this pair of snips is that it cuts the leads without making them very sharp. It's awesome, and of course it is very sharp. It works very good, better than the other snips, but yeah, I like it very much so far. Of course, bought it from eBay for a very low price. Let's get these diodes in here. They are marked with a stripe on the board and a silver band on the diode, which correspond, yeah, something like that. Sometimes English words, I don't know. Me being Dutch, talking in English all by myself, sometimes it just doesn't go as fluent as I want it to. I need the last one. And since besides speeding up, I'm not editing videos. I'm not, most of the time, I must say, I'm not cutting out things unless I've said something really stupid, which I shouldn't have, but that does not happen very often. Most of the time I don't edit my videos. Of course, I'm connecting pieces of video together. That's what I'm doing, and I'm putting the caption on there with my name and the copyright right below. But other than that, no, I don't edit videos a lot. Mainly because I want it to be as real as possible. And the other thing is, editing videos takes a lot of time. Making the video probably is probably quicker than editing it. That's better. That's the full bridge rectifier. This one goes to the LED. Here's AC in. AC in. They made some attempt for separation, but not that great. Then again, it is a full bridge rectifier. Positive is the longer lead, which goes on there. And it's printed as if it is bent like that, so let's do that. Maybe if I don't do it, it won't fit. It needs to fit in there, so. And if it is bent, I have some flexibility later on, so. Alright. Now the main capacitor, which is the main part of the capacitive dropper circuit. Now, as you can see, there's another hole over there. Let's get it in focus actually, and that's probably for this board is probably built for capacitors one type larger than this one. So, and let's see, should we bend it over like that to make it fit? Why not? It is not really pretty now, is it? But does it fit in there somewhat? Yes, it does. Great. Then I'm happy. Right. Let's cut these away. And then connect the AC, or should I do that later on? Probably do that later on. Power supply is finished. Let's insert the LEDs. I need that later on. How? Like that. That's how. Now they look like straw hat LEDs, but they are not. Let's see if I can get that a little bit better in focus. There we go. Just some very cheap 5mm LED without the edge with normal LEDs have. So let's see. They are all marked with pluses and minuses, though that's nice. Let's start actually with the middle one. Again, the for this LEDs it's the same. Longer lead is the positive. And let's start with the middle LEDs. Now let's first connect, to each leg of each LED, then reflow of heat to pad again, and then push the LED in its place so that it is sitting directly on the board. Now it is. Now I can do the other ones. Oh, this also has one very nice 80s style smell to it. Really like it. Brings back memories. But I guess this is getting very boring to watch. So now I'm going to edit my video, and I'll leave the camera running, but I'll edit it and speed it up. Right, that is all the LEDs done. Don't know how much there are, but that is actually interesting to know. Let's count them. Well, let's speed it up also. Now, these are 38 LEDs, and if I've seen it correctly, they are in series per 2, if I'm not mistaken. So 38 divided by 2 is 15 plus 4 is 19 LEDs. So there's a total of 19 LEDs, and they're probably 3 volts. These probably white LEDs. So 19, that makes 57 volts, which this power supply needs to put out. Now the great thing, and I'm going to measure that, of course. Great thing about capacitive droppers is, if I made a short circuit on here, if I made a mistake, and there is an inrush limiting resistor on this one, it will go up in flames. But let me see, let me double check if there is one. AC goes in here, goes through the bridge rectifier, and only through this discharge resistor, and the other resistor is over there, goes to the capacitor, and where's the well, like I said, there are 3, and through the bridge rectifier, AC in. Then probably that resistor will go up in flames. Let's see what we can do. These very thin wires goes to the LED, the positive. Let's see if I can get it to hold in place like that. Probably not. Even insulation comes through the board. Oh, now it is left. Oh. Come on. Help me out here, come on. That looks a little bit like it. And the wire is still on my desk. That's great. Let's push it in and reflow the solder. Let's see. That's better. Now I've made a short circuit. Is it supposed to be? Yes, it is. So that is no problem. And this is the positive. So they are both black wires. So I'm very thin. Oh god. Positive goes on there. Now these are also they've made holes for this one, but that just not sound like a good idea to me. If they're sticking out too far and you can actually touch them, there's a good chance you're touching live wires. So we're not going to do that, because that's how the capacitive dropper works. And I'm going to put it on here like that without pushing it through the board. And the negative one is over there, marked with G and D for ground. Put it on there right away. There we are. Let's see if I can push it through the board on this one. Like I did before, insulation also comes through the board because these wires are too thin. Now it is in place. Let's see if I can keep it that way while soldering it. Looks good. Right. So AC in. These wires are a little thicker. Alright, so let's make sure there are no metal parts on my desk. Let's put it on there like that. I'm going to find a socket where to put it in and see if I can get it in an outlet. I'll be back in a moment. Now let's screw it in. Let's actually not rotate the parts. I don't want my... Oh. And the plastic holder just broke. Was it a clear break or was it glued? It probably broke. Oh, okay, can fix that. Let's put it on there like that. No metal parts on there. Let's actually get a little bit more over here. See if it stays there. If nothing goes bang, the white LED should light up if my wire is long enough. And it does. And it's probably swamping out the camera. But ooh, it is actually very bright and flickery. Ooh. Now, since there is a discharge resistor, I can probably safely touch it. That still works. There we are. Let's see if I can get it on there, in there, like that. And yeah, these metal parts can touch each other. But I do have a crimping socket which is large enough. One moment again. Now, the crimping socket largest I have is this. It won't fit on there, so this will have to do. I hope it just doesn't, it will never touch. Hoping is the best I can do for this. Actually, will it hold? A piece of hot glue is probably the best idea, although it can get quite warm. Let's see. So a way to put it in there is just ram it in, and this probably is. This probably is it, and maybe this just is meant to be, because otherwise you won't get it in there. Let's double check with one of the others. No, this one is entirely solid. So this one is just broken. So it's, but it looks a clean break to me. It doesn't look broken. It just as if it was meant to be. Well, at least now I have a nice light. Let's see if it still works. And let's find some empty socket below my desk. That's probably a little bit too hard. Let's try it on here again. Still works. Probably cannot see that on camera, how flickery it is. But it is, I'm waving it very hard right now. It is not that bad actually. It's not great, but, and the color, how is the color? It is warmish white, but purplish white. It isn't great. It is okayish. But I said that I wanted to measure the let's see, the output voltage. So, which would mean I need to put it on and poke around live wires. Why did I say I want to measure it? I'm not gonna do that. I don't have enough balls for that. Well, let's just accept that it is putting out 57 volts. I'm happy to accept it, and poking around here may short these out, and these, it doesn't look like a good idea to me. This whole kit actually does not look like a good idea to me, to have this in my house with these loose components in there without proper shielding. So it was a nice kit to build, but I'm not going to use it. I don't think it is safe enough for in my house. If I had let it on and I'm not within, not at my house, and I let it light up, keep it lighting, yeah, and something happens, I'm not quite sure if the insurance would pay out. Other than that, it was some nice therapeutic soldering. Thanks for watching.